off we go. So yeah, let's scroll down to, we talked about social media, how that is a very interesting place. We talked about Python, and now let's come back to just like in general. We've got a bunch of cool stuff in the world thanks to digital technology, the internet. Is that a good thing? Is that a bad thing? Like, there's downsides. We've talked about the downsides, but we still want to use technology, right? We're not just going to go live in a cabin in the woods for the rest of our lives. So, like, what can we do to like understand where we're at when we see some new technology? Maybe like, how can we evaluate it? So let's talk about some stuff. Just have some anecdotes, I guess, or some examples. So let's first talk about deepfake. Have you heard of this? It's pretty common by now, right? It's when you change the all the frames of a video. You can change a video using AI. Oh, is it going to stay on? There it goes. So yeah, deepfake is just like you use machine learning or artificial intelligence for sometimes swap faces in a video or change other things too. So like everybody was like, when this first came out, everybody wanted to make memes of changing every face in every movie to Nicolas Cage, which was fun. But of course it can be used for bad things as well. All right, so this is kind of new. Like, this is relatively recent, this idea of changing faces in a video. It's not that new for images, right? So like people have had Photoshop for forever. They've been changing faces in images. Like, that's easy enough to do. If you take a graphic design class, you can pretty easily figure out how to change one face into another with Photoshop. And so that's been around for decades. But videos, right? It's a lot harder. Videos are made up of a bunch of frames, a bunch of different images, and you have to change like the expressions on people's faces. It was a lot harder to do that before like AI rose up and gave us this ability. So videos used to be like really good proof that like a person was in a room, that they said stuff. We can change people's voices with AI now too, right? So that's a bit of a problem, isn't it? Like, now your security camera footage, if somebody got to the recording and doctored it with deepfake stuff, now you don't even know if somebody was in the right room anymore, do you? It's very interesting, right? And so it's obviously you can start using this for fraud, for hoaxes, and like for the memes as well. But you can see the downsides as well as the upsides, I hope. All right, it's crazy. So have we tried to make deepfakes before? Is that like accessible to us? I don't think I ever tried to do it. But, like, are there websites for that nowadays? Honestly, don't know. So that's a thing. Let's see. Let me cut the glare slightly. Slightly better, at least on a cloudy day. All right, so there's deepfakes. Let's also talk about like the place that we love to go to when we're writing essays, right? Wikipedia. Everybody, like the upside and the downside of Wikipedia is kind of the same. So Wikipedia is really nice because it has a lot of information, and anybody can add to that information as like new stuff comes out. They can immediately put it on Wikipedia. So Wikipedia is always up to date, essentially, right? People are adding articles, updating articles every day. So like the article that you go to, maybe it's that today, but new stuff comes out and it's that tomorrow. It's pretty nice. So it can change. All the information on Wikipedia can change. Hopefully we know that. And so as more stuff comes out, they can update their articles, and yeah, that's really nice. So Wikipedia is like the ultimate news article because of that. And so we like to go to Wikipedia to like get some initial information about stuff for essays and other things, right? And the glorious thing about Wikipedia is the reason they can stay up to date so fast is anybody can make an account or just anonymously make a change to Wikipedia, right? You can edit an article and you can add the new stuff, right? But that also means that you can vandalize the pages, that you can do bad things, right? So you can edit any article. You have that ability. You right here at the college, you can go open up Wikipedia. You can be like, all right, let's go to the Clovis Community College Wikipedia page, and we can change like the picture of the mascot or whatever to a picture of our cat. Okay, like that is totally possible because we have that ability on Wikipedia. So it can sometimes have incorrect information or weird information, but the hope is that with a popular enough article, people are going to come along and like fix it eventually, soon, hopefully. All right. At least for like pure vandalism, like you start saying bad words or something or do something silly, Wikipedia has like machine learning or just like software involved on the back end, trying to figure out if somebody wrote something silly, and it can automatically remove vandalism a lot of the time if it's like simple. But sometimes it's very subtle, and people are writing weird, subtle things, and another human has to come along and be like, oh, you know what? That change is not the right kind of change, all right? So that's the thing. And like everybody's trying to make it better. You probably been on a page that like needed to be updated, and like you saw a bunch of citation needed stuff. They're trying, all right? So have any of us gone to a Wikipedia page and seen it like say something wrong? Or have been vandalized? No? I have. I have an example on this slide. Like here's a silly example. I don't know why, from Reddit, I think. I took a link from Reddit to the page on the California grizzly bear for some weird reason. And then just on the very first line, obviously that's vandalism, right? And so maybe 5 minutes later it was changed, but like some people are going to see the vandalism, right? It's going to be there. So that's a good example. I took a screenshot because I knew I wanted to use it for this class. Like that's the last time I saw vandalism on Wikipedia. Yeah, but now the age-old question is that does that mean like we should not trust Wikipedia? Like how do we evaluate our software that we're using here, or our websites that we go to? Like, does that mean Wikipedia is just like we should never use it ever? Or does it mean maybe we should just take what we read with a grain of salt, or maybe go to the original sources? Yeah. Any thoughts on that? Questions? Comments? Surely every English teacher you've had, right, has drilled it into your brain to not cite Wikipedia, right? What you want to do is go to the articles that are cited in Wikipedia and go read those. Then it's probably okay, all right? So as long as you don't use it as your one-stop shop for knowledge, I think Wikipedia is a good idea to go and use, okay? But you could obviously disagree with me. But I think that's what I wanted to say about that. So there are upsides, there are downsides. We have to meet in the middle somewhere. We have to find a nice happy medium where we could like not fully trust the thing, but also use it to our benefit. Okay. So there's that. What's another good example of software where you maybe have to be a little wary? So here's a fun thing. Are any of us going to be engineers in this class? Any of us? Computer scientists are all something completely different. Nice. All right. So one day you maybe will like work at a car company and you'll design cars. So it's very important that the cars that you make as an engineer are going to be safe, right? So we like to run cars into walls, don't we? To make sure that they're going to like crumple in the right way and not hurt the people inside as much as they could have otherwise. So nowadays, we also, in addition to running actual cars into walls, we simulate car crash tests in software. All right, so it's kind of interesting because, as you can imagine, it takes a lot of money to do a real car crash test. You got to build your car, take your car prototype. There probably isn't a manufacturing line for it yet because it's brand new. It's like it takes a while to build, and then you put a little crash test dummy in it, right? And then you send it flying towards a wall. Yeah. There's like a commercial from my childhood that had something to do with this that I vaguely remember. But that's the thing, right? And that's going to cost a lot of money. It's going to take a while, and who knows what kind of information you're going to get out of it. You do need to do that eventually, probably for safety purposes in a lot of countries. But what if, and people have done this, what if we just like model the car? In software, we have 3D models of all these things, probably. Because that's how engineers build stuff. They make the 3D models before they're made in real life. And, well, if we got all that, why don't we just, like, make a 3D model of the car and send it into a 3D model of a wall at a certain speed? So let's see that. And that would be free, right? It would just take computational time, and they already have servers at the car company, probably. What's wrong with that? Is there anything wrong with that? Is that a good thing? So there are good and bad things about this. Okay, it's great because it saves you money as a car company, but it is also very hard to model every little intricate detail of a car. It's really hard to do that in software because think about it. You want to model, if you want it to be perfectly accurate, you have to model every little individual atom of each different kind of metal and plastic and all those things that make up a car, right? And only once you have that can you accurately figure out what it's going to do when it hits a wall. We cannot make it that accurate. It's impossible. So we have to like throw away some information, don't we, when we're making those simulations? So like we do know, we have a lot of physics knowledge if we've taken a physics class, right? We know what things should, how things obey the rules of physics, but we just can't, like, we don't have enough storage space to model every atom of this car. And so that means that the answers that we're going to get from the simulations are not going to be perfect. They're not going to be exactly what we get from real life. Okay. So that means they have to make some simplifications. Just like, all right, let's model every material on the level of like a square centimeter or something. Every square centimeter now gets modeled, and we know what happens to each of those, but it's not the same as atoms. All right. And so, interesting, right? The question is, like, if we take all this, we put it on a computer, is that still okay? Like, are people safe still if we do that? What do we think? Should we have car crash test simulations, or should we just be building the real cars? Because we do have to throw away information. We don't get the full answer with a simulation. Would you buy a car if it was only simulated, the car crash tests? I see some heads shaking. Yeah, I don't think I would either. I want it to be in real life as well, right? So, yeah, the question is this an ethical problem? I think you can see. It's an interesting one. So there's pros and cons to this. One argument for these simulations is like, all right, if they do enough of these simulations, like eventually they'll get it right in the simulation, and then they'll build the actual car and like make sure it follows through with what they saw in the simulation. So maybe they're technically running more tests, even though some of those are simulated. So maybe that's going to let them come across a better design for the car after all, because they get to run more simulations. Technically, they do more tests in the end, simulations plus real life tests. That's kind of nice, right? Then it might be more safe. So there's that. But then on the flip side, that all depends on like whether the simplification was a good simplification. Like it's still an accurate simulation at that point. Because maybe it's not, and maybe like they made some choices based on what they saw in the simulations, but those wouldn't have happened in real life, and so now like they made a less safe car versus if they had done the real tests with a bunch of real cars. Okay, so yeah, that is an ethical dilemma. Again, you can see like there's good and bad. I think we can all find a happy medium here somewhere. Yeah, so that's what you got to do with all the new things that come out. Where is the happy medium where like we could do some of the new stuff, some of the old stuff, but still get some benefit? Yeah. Any questions, thoughts about that? Simulations are getting pretty nice. I mean, just like look at all the video games; those are technically simulations that we play. They're getting better and better. Yeah, just have a few more examples. So. What else? So we have like really nice phones nowadays. Like they don't flip open anymore. They don't do just calls and text messages. Like we have a computer inside of our pockets, really. And what does that mean for us now? So one fun idea is that like Google or even Apple, they can take an app that you've downloaded and get rid of it. They can delete it. That's totally allowed. It's part of the terms and conditions, right? That's totally okay. So Google, for example, if you have an Android phone, they can remove an app from your phone. If you downloaded it, even if you bought it, they can get rid of that. All right. The reason they have that ability is because maybe you have bad things. You downloaded a bad application accidentally or something. It's like trying to protect all the grandmas of the world. But should that be allowed is now the question. Like, should they have that control? Like, it's your phone. Maybe you wanted that app, all right? And they just don't like it for some other reason. Like maybe it's political themed, or like it goes like it paints Google in a bad light or something. You can think of reasons like why Google might want a good application gone from your phone still. Yeah, that's the thing. Should they be allowed? That's a question to think about. Apple also has that ability. They've gotten rid of things. Again, for malicious reasons, they'll take it off the App Store, stuff like that. So, you have a question? This class ends at 12:20. as I was saying, so yeah, Apple can also do the same thing with iPhones. I have to look into this again, but do you guys remember like a year or two ago, they were trying to take down the game Fortnite on the App Store. Do you remember hearing about that? Did it ever come back? I don't think it ever came. Yeah, it's still gone. So the issue there is another problem. So let's see. The issue with that is another thing that you have to worry about as an app developer. Fortnite wanted to like have people pay for Fortnite, and the App Store, when you put an app on the App Store for Apple, they want a cut of what people buy. So like they're going to take a 30% cut of like the price of the app, if there is a price for the app, and then also any in-app purchases that you have through that app that they downloaded from the App Store. So the Fortnite people thought that was silly, and they tried to go around that. And so that got them removed from the App Store because they tried to do that. All right. So that's very interesting. So yeah, there's rules to be on the App Store, and like you have to suddenly give a decent chunk of your money to Apple just for the ability to be on the App Store, which is maybe unfortunate. I don't know. It all depends on your viewpoints. So yeah, if you don't follow the rules, your apps can be removed, and so it is gone. Fortnite is gone on at least the American App Store. In Europe, they've made some laws to go around this. They've made it so that you can have custom non-Apple app stores, and I think Fortnite is on those. So maybe we should be like the Europeans or something. So that's a fun idea, a fun thought that's recent and relevant. And then here's another fun one. Amazon has the little ebook readers, the Kindles, and so here's a funny example from your book. One time, Amazon, just for fun, I think it was accidentally, but it's hilarious that they remotely removed copies of 1984 from a bunch of people's Kindles. And so if you've read the book, you understand the irony there and how hilarious that is. But, like, that is the ability that we give the makers of the products we use. Should we be giving that to them? Should we be making laws that don't allow that unless like there's a court case or something? I don't know. Yeah. What do you think? Again, ethical questions, things that you should think about because you're using these things. Right? So it's always like, don't just use a thing, think about it. That's my moral of this story. Okay. So there's that. Also, let's talk about upgrades because this is also recent. So at least at work right now, this laptop that my work gave me, the school gave me, is it's on Windows 10. And have we been nagged on Windows 10 to upgrade to Windows 11 before? No? That is a thing that Microsoft did that was even worse back when it was Windows 8 and then Windows 10 came out. So Microsoft kind of forced Windows 10 on a bunch of people back when Windows 8 was like getting old. They forcibly upgraded everybody's machine to Windows 10. Should that have been allowed? Is that a good thing? Is that a bad thing? Because again, it's about control. It's just like these app stores. The question is like, I bought this computer. Do I not have control over which operating system, which version of things that I'm running on my computer? Because like you've given up control at that point. Like Microsoft, should they have that control over me? I don't know. So again, you can make a pro-con list. We can ask our boys if we needed to. But like some arguments for a forced upgrade would be that like you want this for like your grandparents. You would like to make sure that people who are not very good with computers are always on the most recent version of software because that's the hardest versions to hack. Yes. So older software there's a reason that older software has been updated usually, and a lot of times it has to do with security things. Like if you have an iPhone, if you like have your App Store upgrades or updates, it always says like bug fixes and performance improvements. So there's like a bunch of bugs that people could exploit a lot of the time, and so it's nice to have that all automatically like taken care of for us. But at the same time, like you bought this particular version of this software, like should we not keep that around? Like a lot of people really like the 2013 version of Photoshop or something. Like if that was automatically upgraded away from them, they would be very, very angry. Should that not be the same for operating systems and software versions? Okay, so yeah, at that time, when that happens, you lose control. Okay, you paid for the thing. Why don't you have the control? Okay, so yeah, I think that's the example there. Have we been I don't know, have we experienced this? Has an app just like the next day been upgraded and like we missed the old version? A lot of websites have done that too, right? Like the new look for, I don't know, Facebook or something, for Instagram. They change stuff and like we like the old stuff. We like the old version. It's unfortunate, right? So that's interesting. And then the last slide for this set of slides before we start some new ones is just I want to talk about equity and equality versus equality in the technological realm, because like COVID made this very apparent. All right, so hopefully we've seen this picture of equality versus equity before. Like equality is giving everybody a box, but equity is like giving people who need some more boxes. And some people don't need a box, something like that. All right. So if you think about this in terms of technology, like when COVID happened, everybody started working online. And a lot of people did not have the technology to do that. Hopefully they got a laptop from the place that they worked or something, or they were just forced to go in for no good reason. All right. So like a lot of low income households, especially, they don't have like super powerful computers. They don't have really fast internet connections. So it's really hard to like even take an online class, right? When once school went online. Now suddenly they can't like experience the class at the same level as their peers. That's an issue. Yeah. Like also like in this day and age, like you need a phone, you need a cell phone, you need an email address, you need an internet connection to even get an interview anywhere to get a job. Right? So if you didn't like that or you didn't have any of that, you're out of luck. So it's very important during the pandemic. Maybe it's over now, maybe it isn't. I'll just keep this line in there. Stuff like that. So like for example, if you don't have a webcam, you can't like go on an online class and take a proctored test, right? You can't do that, which is unfortunate. At least the library here has been really good with equity. They're written out laptops and webcams and even hotspot routers for you guys if you need it. Hopefully you've taken advantage of that if you do. But yeah, it's really unfortunate the differences that are very apparent, right, with respect to like income. Like if you make more money, then suddenly like you can access so many more things in the digital world, and that's a problem, right? Then now there are a lot of things that are unequitable, yeah. And then at the same time, along these lines, if you think about it, a lot of like startup companies in the Bay or something, they're making all this software and then they're testing their software on themselves. And unfortunately, a lot of the time, a lot of software developers are like white people. And so like programs are often tested, like things that involve like facial recognition and things. They're often tested by like wealthy white people, which is very unfortunate. All right. And like even if somebody like gets this nice thing, even though they have enough money to buy this fancy technology, it might not even work for them. So here's a fun tweet, or not a fun tweet, but like a very good example of a tweet that that involves this idea. So I'll just let you read this. And it's really unfortunate, right? So one day when you become software developers, please take these thoughts to heart. All right, make sure that your software works for everybody. All right. So with that in mind, I think we're ready for the next set of slides. Are there any thoughts about this? Have we experienced this? Issues like this before? Depends on who we are, I guess. But yeah, it's really sad, right? It's really sad and unfortunate. So yeah, hopefully we can fix this in the coming years. All right. So let's see here. Let's talk about more bad things with computers. All right, so this will tie into the essay that we got out for you right now. So yeah, let's talk about issues with computers, risks and bugs. So we know about a few risks now. Let's see some bad ones. All right, so I have just some fun examples of bad things. Maybe they're not fun; they're sad examples. Sorry, they're very eye-opening examples. Is probably the right word. All right, so yeah, let's talk about some bad things that happened with computers and software. Try to answer this question at the same time. Like, why, when all these things are going wrong, when software can make things bad for us, like, why do we still care? Why am I still like teaching computer science? So let's figure that out together. All right. So here's a good example. Nobody got hurt. I first want to say nobody got hurt with this example. It was just it cost a lot of money. Is the problem. So this is an example of a rocket that was made not by NASA, but ESA, European Space Agency. So they do that, and they make their little rocket ships too. And they made one called the Ariane 5. All right, and unfortunately, the first launch of the first model of the Ariane 5 did not go well. It self-destructed because it thought something went horribly wrong. Something didn't actually go horribly wrong, but it self-destructed itself 37 seconds after it shot off the ground. So that is very unfortunate. This was in 1996, summer 1996. So 37 seconds into flight, it was like, you know what? Something's going wrong. I'm going to blow myself up. That's what it did. All right. And the reason it blew itself up was because of an issue with the software in the computer that was controlling it. Crazy. So it's like, all right, something went wrong. It was a bug that thought something went wrong. Something did not actually go wrong. And it blew itself up because of it. And yeah, it was almost $500 million lost. In 1996 money, too. So, like, this is decently more money nowadays, isn't it? That is very unfortunate. So, a software bug, like maybe 1 or 2 lines of code even, were wrong. And we lost. The European Space Agency lost half-ish $1 billion. That's crazy. So, we better talk about that and how, what was wrong. Let's talk about what was wrong. And we'll eventually talk about, like, how could we have solved this problem? How could we have made sure that it wasn't going to do this? All right. So, okay. I'm going to say some words, and you can understand these words now. So, the issue with this rocket, the reason it blew up, is they were trying to save some money. The Ariane 5 implies the existence of Ariane 4. They were trying to save some money, and they were using some old code from the old rocket. And unfortunately, the new rocket was faster. All right. So what they did, here's the crux of the problem. They tried to put a 64-bit float into a 16-bit int. All right. I know you know what those words mean, but maybe not, like, in a sentence. So, okay. Remember what a float is? That's a number with decimal places. Right. So the float type in Python is, like, you can hold 3.14. You can hold, like, even very large numbers as well. It has, like, it's capable of holding scientific notation numbers, floats. It's like 5 times 10 to the 50. Like, you can hold those in a float. Int types, though, what's an int type? That's just whole numbers only. So, like, you're throwing away decimal places, first of all, right? -42, 0, +42. And that's a problem, all right? So, if you're trying to go from here to here, which is what they did in code, they're throwing away the decimal places, first of all. And then also, the sizes are very different. And that's going to tell you what numbers you can represent successfully, all right? So 64 bits means you're using 64 ones and zeros. Bit means binary digit, right? 64 ones and zeros to represent your number with decimal places, all right? So that's what I mean by that. Okay, that's this. Boop. 64 binary digits. So they took one that uses a bunch of digits that gave you some very good precision to represent decimal numbers, and they try to take a number and shove it not in that, but into 16 bits. Very small place, which is going to lose some precision, right? And also, it lost the decimal places too, which is not the hugest issue, but maybe they rounded it. They tried to put that into a 16-bit number, and I think you can imagine, like, you can represent way more things with 64 than with 16. Okay, so that's the crux of the problem, and that number that they tried to take from here to here and change its type and all that, it represented something very important for the rocket ship. It represented the horizontal velocity of the rocket, right? And I am not a rocket scientist. I am just a computer scientist. But here's what I imagine the horizontal velocity means. I think it was relative to Earth or something. It's like, here's Europe, there's Italy, there's the UK and Ireland. And so when the rocket shot off, boop, here's my best 3D image. And when it shot off, it's like it doesn't take like a perfectly straight up position, like it's trying to go somewhere, and so it moves a little bit up, and then also like it curves, right? So it's moving straight up, and then also a little bit maybe to the right, like relative to Earth. And I think that's what the horizontal velocity meant, like how fast is it moving relative to like a spot on Earth where it launched. So apparently, either they shot it off at a weird angle, or like it just went so fast, it just did not work out. That you could not shove this number into this number. It was called it overflowed. We say it's like it needed some more bits, but it didn't get those bits. So it thought that the number was either too small or too big. All right, so that's the problem. There was not enough. That's what overflowing means with types. We try to convert types, and it overflowed means that there was not enough room to store that new number properly in that new place. All right, so it thought that the rocket was moving maybe too slowly relative to the ground because there wasn't enough room to represent how fast it was actually going. All right, so that's the main problem, and it just decided to blow itself up because of that. It's like, all right, I must be going way too slow right now, which means I'm going to fall back to Earth. So while I still have altitude, I'm going to blow myself up to prevent like loss of life, to prevent me from crashing into like a building, even though it was going to do just fine if it kept going. So that was the problem. Does that make sense? That was the issue, and it cost a lot of money, and it was a very, like, you can imagine if you just kept the same number and didn't try to convert it, like a couple lines of code would have saved us, would have saved them almost $500 million, right? And the reason, like, they got into this issue in the first place is they tried to be lazy. They tried to reuse old code from the Ariane 4 rocket that either they shot off differently or just didn't go as fast, all right? So they reused old code from the Ariane 4 rocket, and they just thought that, like, back then, you know what, 16 bits was enough for the horizontal velocity. We don't need any more than that. Surely it will never get any bigger than I need to represent with 16 bits of digits, and sadly that was not true for the new rocket, right? So just think about, like, what could you have done to have prevented this? You have any ideas in your mind? That's the problem. While you think about that, let me teach you what overflow means in a different color. Like, let's pretend we have 4-bit numbers. Like, the smallest 4-bit number is 4 zeros. The largest 4-bit number is 4 ones. But if these are all you get, say you wanted to add 1 to the biggest 4-bit number, what happens? You want to add 1 to the 4-bit number 1111. If you add 1 to that in binary, what will happen is, like, 1 plus 1 is 2, so 1 0, 1 0. You keep carrying 1 0, 1 0. And then, like, you carry out a 1, but there's no room for that 1. Like, this would be the final answer, but we only have 4 bits of space. So, like, you throw it out. And so what should have been a big number becomes a very small number. You see the problem there? That's what overflow really means. And that's what happened. All right? So maybe the rocket thought it was going way too slow, and it decided to blow itself up. So, yeah, when you become software engineers at NASA or something, you better watch out for that. Okay? That's a fun example. Now I just have more and more sad examples. So this was an unmanned rocket, so this is fine. Slowly but surely I have more examples that get unfortunate with humans. So let's talk about voting. Voting is very important. There can be issues with electronic voting systems. Several states use electronic voting systems. Several countries use it too. So here's some examples from your book. Right? So this is very unfortunate. Sometimes, back in the day, maybe recently even, this is still happening, but if you're going to vote in an election and your county only uses electronic voting systems, they don't use paper like we do in California, then if something goes wrong with the system, like the network goes down, they crash, suddenly you have voters that are unable to vote, like if there aren't any backup plans and there's not enough paper to write down their votes on. Do you see the problem there? That's an issue. So now suddenly, like, maybe somebody who was not supposed to win will suddenly win because of that. So you can think about how that could be turned malicious as well. There's that. One county back in the day, they lost a couple thousand votes, which is not the hugest number, but maybe for local elections that's important. One county lost more than 4,000 votes because the memory of the machine was full and they couldn't tell. It's like, I've stored all the votes I can store, can't store anymore. But they just kept going. They thought it was fine. So that's unfortunate. In one county in Texas, a bug in the code generated 100,000 extra votes for somebody. I don't know if it was the person who won or not. But that's really bad, right? Now suddenly you have election fraud as a possibility if you have electronic voting systems. But luckily, maybe they understood, like, okay, yeah, 100,000 votes did not come from one machine. Like, they understood that, and they figured it out and fixed it. But when you stop using paper for counting votes, now suddenly you can have these problems, right? They need to be solved. This needs to be a very accurate number if you're going to elect somebody, right? Another bug, programming error, caused some candidates, the worst one, caused some candidates to receive votes that were cast for other candidates. So, like, you voted for one person, it suddenly, like, votes you for somebody else. That's the worst one, probably. Luckily, it sounds like since they wrote this down in the textbook that they figured out the problem and they noticed it before, like, somebody got elected. But, like, that is a huge issue, right? So, you can kind of see with these two examples, like, nobody got hurt at least, but you can see that it's very hard, right, to write software that is perfect. You've been doing this this whole time in this class, right? Your first version of your programming assignment is not usually correct. You have to keep going back, iterating on it. And that's true in the real world too, right? It's very hard to write software that's correct, that's safe, that cannot be tampered with. It's very, very hard to have all those things, right? But sometimes you can get it right eventually. Like, you do it enough, you can get it right. But it takes a lot of effort. So, for example, in Estonia, smaller country in Europe, right, they can vote online. That is fine for them. And, like, it's secure enough. It works out. There's no issues with fraud. Like, they're fine with that. But are we okay with that? Would we be okay with, like, logging into the internet and using that to cast our votes? Would we want to do that? We're just used to voting on paper. But maybe this is the future. I don't know. But it's also a cultural thing. Like, we're used to one way and it's hard to change. But if you can get it right, it'll save you from having to go into the polls, mail stuff in, right? That's important. So, yeah, that's a problem. And now let's talk about the worst one where people actually got hurt. So you've been reading about this, right? So in your essay, you're talking about the Therac 25 machine. And let me just give you the quick play-by-play. You've read the article by now, I think. So yeah, the Therac 25 machine, very, very sad story in the 80s. It was a radiation therapy machine controlled by a computer. So it was helping people who had cancer, right? You're supposed to shoot radiation at the cancer, and it's like fighting fire with fire that will cause the cancer to, like, die off and save the human. So yeah, this machine was made in 1982. That was the first time it was, like, released to people and they could use it in doctors' offices. And the first time an issue with it was documented was 1985, 3 years later. But you can imagine that there were plenty of cases where it was going wrong but before that. So yeah, it's very, very sad what happened. But there were some issues. You've read about them, right? There were some issues in the design of the machine and also the code that was written that very sadly ended up giving people who were, like, using this machine to be cured of cancer, it ended up giving them up to 100 times the amount of radiation that they were supposed to have for their treatment. And so this machine that was supposed to help people get cured from cancer was giving them more cancer. And that's really, really sad. All right. So what was going wrong was this. There was a little, I'm not an engineer, but the idea is, like, it's going to shoot out radiation at you. There's, like, a beam. There's, like, a little gun inside of the machine. And it's shooting out radiation after you've controlled it and programmed it and turned it on. It's shooting out radiation at the spot that you've, like, put it on the patient. And in between, while you're configuring the device, there used to be, like, a lead plate or something that was in the way of the beam. This electron beam that was shooting out radiation, there used to be this little plate in the old version of the Therac machine. It was like Therac 20 or something. There used to be that plate, but then they got rid of it. They got rid of it in the new machine, right? In previous versions, the machine had a hardware system to block excess radiation while the machine was being configured. They got rid of that. They thought the software was fine, but it wasn't. And now, in between treatments, while the patient was still lying there, it ended up giving them a lot more radiation than they were supposed to get, and people got even more sick, and people died because of this, right? Because of a software bug, because this beam was shooting out radiation when it should not have been, right? We read about this, right? What are our thoughts? what do we think about this? I'm excited to read your essays. A very somber story, though. Very sad. Well, I'm going to force you to think about it now. I'm going to force you to tell me something. So here, I've got an example. I've got a debate for us to have, all right? So this time, please go to the written nice page, and I'll stop attendance after you've done this. Please go to the written nice page, and I'll clear it out. You can elect a leader of your group. Please get together, discuss the sad little incident that you've all read about now, hopefully, and try to tell me this, right? So things have gone wrong. People are dying. Whose fault is it? Is it the programmer's fault when something bad happened and like people ended up getting hurt? I want you to answer that question for me, please. All right? Is it the programmer's fault when something bad happens in a device that maybe is supposed to try to help people and somebody ended up getting hurt? All right. So this time I'm not going to give you a stance because like this is very, very sad and serious. So this time I'd like you to answer this question both ways. I'd like you to try to think about both sides. Please come up with at least one good argument for each side as a group, please, and write it down. All right. So tell me why it is the programmer's fault. Give me some reasoning behind that, and then also tell me why maybe it's not the programmer's fault, and give me some arguments for that as well. Does that make sense? So yeah, please get together, discuss this. I think it's going to be a very good discussion. I'm excited to see what you think. I'm very interested. Whose fault is it? All right. Tell me why. Why it might be the programmer's fault, why it might not be the programmer's fault. We got plenty of time for this. What do you think? Good thoughts. Keep it going. Give it a couple more minutes. All right, I hear the voices dying down. Was that enough time to get some ideas in? One idea for each side. Press submit. Give you 30 more seconds if you're still typing stuff. Okay, so we did that. 3, 2, 1. I should have pressed submit so I can see it. All right. Well, let's see. This is, sorry to give you a sad topic on a rainy day, but it is very important to talk about. All right, so let's see our ideas. Like, why might it be the programmer's fault? Why might it not be? So, all right. Group 46 is the programmer's fault because he's the one that programmed the code and people got hurt. It isn't the programmer's fault because bugs happen all the time. Maybe the programmer ran the program multiple times and nothing happened on their end. Yeah. It's hard to notice things that are wrong. So that's a very good idea. Let me start at the bottom as well. So I never get to the last one. Let's talk about the last one first. So, very nice, Group 51, for writing a bunch of stuff. So why might it be not the issue that the programmer is responsible? The programmer may not be held solely accountable if they have diligently followed the industry best practice. Like they did their job as good as they could have done. I think that's what you're saying, right? If they did it as good as they could have done, like why blame them? They did some testing, they adhered to all the safety protocols that were in place. Like if they checked all the right boxes, then it was just an accident. Yeah, it was unintentional, potentially unforeseeable. Yeah, very good. Like maybe the people who were using the software, they didn't use it right. That's another problem. Like it could have been the user's fault as well. Though maybe you should have made the software impervious to the user's issues, but that's hard to do. So good. That's a very good argument. And then why might it be the programmer's fault? On the other hand, the programmer could be held responsible if their negligence, such as cutting corners, ignoring safety if they did something that they should not have done, and you can specify that, then it makes sense to say that it's their fault. Disregarding potential risks, good. Yeah, harm might have been preventable had they acted responsibly and ethically. Yeah, so that's what we like in all of our software engineers. So if you ever become a CEO of a company, you're going to make sure you hire people that adhere to all the safety protocols. They do a lot of testing, all right? So here, let's do one more. I'll read Group 49, just like zoom around the place. So is their fault because is the programmer's job to check the software before sending it out? They should have made sure it was working properly, all right? So, yeah, could be their fault. Then it's not the programmer's fault because people make mistakes, and there should be a lot of people who are working on it. Like, it shouldn't be just that one programmer's job to check for stuff. All right. So yeah, that's the idea. Dun, dun, dun. I think these are good thoughts. So good job. Good thoughts there. I promise to stop that. So yeah, if just a programmer, they're working on something and it went wrong, he or she should not be blamed. Yeah, sometimes, but maybe if they did something really wrong, that person maybe should take some blame. So there's two sides to that coin, and good job for noticing those sides. I just have a slide to just like talk about all that. So yeah, the question is about assigning blame. It's very hard to do, honestly. I can tell you right now, it wasn't just one person programming the Therac 25 machine. In every software company, there's always a team of people working on stuff. So it gets even harder to assign blame, right? So people usually, they work in large teams, and they have little tiny pieces of software that they're working on themselves. It's like me as the programmer, if I get assigned this little piece of code, I go and write it. It works in a nutshell at the level that I understand it, maybe. Like I program this code, like it works as far as I understand the specification, then I give it to somebody else, like we put it in the bigger piece of code inside of the machine, and now suddenly it could go wrong. Do you kind of understand that? Like maybe it works at the level that the programmer understood it, but like in the big picture, which they weren't told, now suddenly it doesn't work. That's a possibility. Like they don't know that big picture because they're just like, they're down in the weeds. They're working on the stuff that they were told to work on. And then also, like, it's so easy to have bugs. You've written so much code in this class by now, you know that it's very, very hard to do it right the first time. Yeah, I've made plenty of mistakes during lecture. It's hard to make a program that does the right thing the first time. It's very easy to make one that goes wrong. And so, like, the question is, how do you systematically figure out that no, something's wrong, I need to fix it? The main solution is these ideas, which a lot of you wrote about. Like, I should be testing this code that I wrote in some way. I better be testing it as much as I can. I want to try to verify that it's working. All right, testing and verification, those are two key terms in computer science. All right, yeah. For a weird reason, testing means one thing and verification means something slightly different for computer scientists. But to you right now, they probably are synonyms, but I'll talk about both. So let's talk about testing. Like, that's one thing that they should have done more of, for sure, in the R25 machine. There are people that are hired, there are software engineers that are hired to just do testing, not write any actual code, just do the testing stuff. That's very interesting to think about. Maybe that could be you one day. You want to go look for bugs. So yeah, it's very important to test your code. It's one of the easiest ways to find problems, though it won't find every problem. All right, but here's the idea of a test. All right, here's your code, or somebody else's code. You treat it like a black box. You don't know what's going on, but at the end of the day, code that you write, it takes input, right? It takes input like 42, and it produces output. All right. So the idea of a test is to give your code something that you understand, like give it 42 as an input, and then go and check and see if the output was what it should have been. Like maybe it's supposed to be 13. Then go and check that. That's what it means to test things. Does that make sense? It's like go and like hard coded input, make sure that the output is what it should have been. That's a test. Okay. Like try as many as you can. Try as many that you think would cause problems. Like maybe 43 was supposed to do something else, but like it produces 33, and that's wrong. And that was a failed test. Okay. So the more tests you write, the more confident you can be. You can't like write a million tests. So, and unfortunately, people like there's a stigma against writing tests, and people don't really like it. But I think we can all agree that it's very important to do. So at the end of the day, all a test is, in terms of software, is you try an input, you verify the output. So example test. An example test is like try input 42 to the program, and then just make sure that it is the answer that it should have been. Like you know what it should have given back. Confirm that the output was what it should have been. Confirm that, let's say it was supposed to be 13. Confirm that the output is 13. Okay, so that's all it means to test. And let me give you an example of that. I promised, or I think I lied when I said we're done with Python, or we're done with Scratch. I'm going to do Scratch one more day. I have one last example in Scratch because we don't have like if statements in Python yet. I don't have if blocks. We need that to do testing because it's like, if it worked, say that it worked. If it didn't work, say that it didn't work. So we need that. So here, let's make a silly program and some tests for it. All right, let's make a new block that is going to multiply some numbers together. So like multiply the numbers from 1 to 4, and its job will be to like produce 1 times 2 times 3 times 4, like a factorial kind of thing. It's like 4 should be giving back, what is 4 times 3 times 6? It's 24, right? Like the answer should be 24 if you give it 4. Does that make sense? And that could be a test. It's like, all right, if I gave it this, make sure it gives back this for me. All right, so let's make this block, and then we'll write some test cases for that block. All right, so here's how I want to program the block. First of all, just in code, I made some variables. Like we're given this number here. I'll call it num. Our block is going to take a number, and we need to compute a product based on that number. Product. And so I want to produce like 1 times 2 times 3 times 4. The easiest way to do that is to go backwards. Start your product variable at 1, because you have 4 right now in this variable. You're going to get that. Like multiply 4 into product, then make num smaller. That will be the code, right? And then multiply 3 into product, 12, make num smaller. Multiply 2 into product, make num smaller. And then you could stop when it's 1, or you can multiply 1 into product, still 24. Make it smaller, and then the second you get to 0, that can be your stopping condition. All right, that's going to be the algorithm, and then like display the answer, something like that. So let's write the block and the program, and then we'll do some tests. All right, just like confirm that it does the right thing. So I'm going to go to Scratch. I think this is the actual last time I talk about actually do Scratch in the lecture. So usually, sometimes I have to refresh. Yep, suddenly it works this time. All right, cool. So let's make a new block. I'll just do this quickly. Multiply the numbers from 1 to 2. And we want this to like take something, and so you can click this add an input button right here. And I'll call it n. All right, that's what I'm calling it, I guess. Or should I call it? No, I'll call it n because I want to make another variable called num that I can change. So there. Multiply the numbers from 1 to n. That is my block. Okay. And now I can use it as much as I want. Like I want to use it with 4, for example. But every time this runs, I need to give meaning to it. So whenever this block runs, remember it's going to jump up to the definition block. And it'll start running the code. And this time I gave it something. Like, all right, it takes this number here. And I have this number as a special variable. It's like when I run this with 4, it jumps up here and it sets this special n thing to 4. Whereas if I had run this in a different way, if I said multiply it from 1 to 2, it would jump up here where n is now 2. Does that kind of make sense? That's how it's going to like let you run it with different things. You're getting the different value. It's like whatever was given to you is like it makes a special variable for the defined block on the fly, which is very cool. So now, unfortunately, you cannot like this is just like the input variable. You can't mess with it. And so I'm going to make some new variables for myself. I'm going to make a product and a num. So this is just to get the code working. This isn't even the main issue right now. So we want to get to tests. So I'm just going to do this quickly. All right. So num and product. So all right, I was given a number up to n. I want to multiply into. So I need to set product to 1 to start, and then num. Let's set it to whatever we were given. So product and num, please start out in the following way. We're going to multiply into product, so better start at 1. And then num should be whatever n was, because now I can change num, because I need to make it smaller. That's what I wanted to do there. And now it's going to be a loop. All right, so loop until num is 0. Until num is 0, like keep multiplying into product, making num smaller. That's going to work. So it's going to be repeat until num is 0, something like that. Dun, dun, dun. Because it's num that changes, not n. Num is equal to 0. What do I want to do now? It's always multiply num into product, decrement num. All right. So set product to be the multiplication of whatever product used to be by whatever num is right now. So to multiply like the 4 in the first time, the 3 in the second time, the 2 in the next time, because each time we're also making num smaller, so I'll change it by -1. And it's like that's how it's going to work. And just to watch it work, if you ever wanted to, you could do you can do a wait block just to watch it work. But like here, let me click this block, and in theory, like the answer should be in product should be 24. There goes 24. Yay! So it is working. And then maybe the scratch cat should like output that or something. I don't know. Say the answer for 2 seconds and the answer is in the product variable. Yeah. So like there's the code. Hopefully that makes sense to us. This is just a review. This is nothing new. Like I made some code, now I want to test it. All right. So the idea is like I need to try it a bunch of times to see if it actually worked. Yeah. Like we've got the code. And so what are some tests? Like this could be a test. Like 4 could be a test. And what we want to do, we want to make sure that the answer is 24, right? So like maybe we can leave ourselves note. Like this can be our test. Make sure answer is 24. Like that's a thing. And there's one test. Click it. Does it work? So it's 24. Cool. So that test passed. Okay, you see it? That's what you want to do. You want to make a bunch of tests where you know the answer. Like, all right, if I run it with 2, the answer should be 2 because 1 times 2 is 2. Right? So this should be 2. You see it? Those are some ideas. And that's another test. It's like, all right, try that one. 2, cool, it did work. Awesome. And yeah, you want to check like corner cases. That's an important word. And a corner case is just like where things like stop making a lot of sense. Like it's a little weird. Things work a little bit differently in your corner cases. So some good corner cases are like numbers that skip this repeat until block, like it's already 0, maybe, like skip the block, or numbers that will only run the body of this loop just once. So like the number 1, for example, would only run it once there, right? 0 would skip over it because it already is 0. Does that make sense? So those are corner cases. Those are edge cases, right? It's like there are cases where it's almost correct or not correct, or where the program is about to do something different, like run the body once, run the body 0 times, like 1, 0, and 2. Those are good cases. Like, all right, if we say 1, the answer should be 1, right? Well, the numbers from 1 to 1 is just 1. So, like, does that work? Let's try. Multiply the numbers from 1 to 1. Should be 1 still. Boop. Luckily, our code will work properly. But then, what are the others? Like 0. What happens? And like, this is forcing us to think about the potential issues. If the user gives me 0, what should the answer be? What does it mean to multiply all the numbers from 1 to 0 ascending? It doesn't actually mean anything, does it? So it's up to you, the programmer, to decide what happens. But that's an error case, right? You're just suddenly thinking about these things helps you understand these, right? 0 should not do, what does it mean? What should it be doing? Duplicate. Multiply all the numbers from 1 to 0 in order. Should be question mark. Should be an error, right? Who knows? What is it going to do right now? It's just going to skip over the loop and product was already 1. So it's just going to set it to 1. That's probably not what you wanted, though. So, that will tell you, maybe we should add an error case for that, right? Same for other things, these cases, test something that's completely incorrect, multiply all the numbers from 1 to negative 42 in ascending order. That's a horribly incorrect thing, but the user can type whatever they wanted, right? So we better be checking that. Maybe that should be another error. It's this is forcing us to think about what could have gone wrong. And this is a great example because this one's never going to reach 0. It's already started out with num less than 0. Num will never be equal to 0. And so you see how it's getting bigger and bigger. It's going to be stuck in this loop forever. It's an infinite loop. So that's a huge problem, right? So that's something we need to notice. So that should also be an error, yeah? And so we can cut those off with an if at the start. It's if, and that's forced us to solve this problem, right? If, oh gosh. If the number that I was given, I don't know, I'll just do it with n because I did it in that order before num got set. If that n was less than or equal to, if it was less than 1, let's say, all right? If it was less than 1, then either it's 0 or it's negative, and none of those numbers make sense. Multiply the numbers from 1 to 0, 1 to negative 42, will be in here. And what I want to do is yell at the user, invalid input or something. Something like that, and then we'll stop the program so that doesn't continue. Does that make sense? That, we discovered we needed that from our tests. And then this is, I need to move all these now. The first original test for the 4 still works, luckily. You gotta check all those too, if you add new code, does the old stuff still work? And now suddenly, this one, invalid input, perfect. This one is also invalid input, and it does not get into that infinite loop anymore. You see it? So that's what you want to do. That's how you test stuff, okay? And yeah, as always, you have an idea of your mind, how the code should have run. You're going to compare what you got back from your code running with what you expected to see. That's what it means to have a test, right? So you try your corner cases, some completely incorrect cases, and then you also test some numbers that that are normal. 4 we tested. You can test another just to be confident, but I think I'm good enough with 4. And so once you have all those, you haven't tested every number that the user could ever give you, but you've gained a lot of confidence that it's going to work. All right, it's going to work when the loop runs a couple times. It's going to work when the loop runs 1 time, 0 times. When the user gives me very bad input, I've figured out what it means to get bad input, and I'm going to give back an error in those cases. Make sure it all checks out, so you can be very confident. Even though you didn't test every infinite number there is, the code's probably going to always work. Does that make sense? Can't test everything, but you can gain some confidence this way. And that's what it means to test things. You're always comparing what you got with what you expected to see, and if you can write as many tests as possible, the more you do, the better. All right, and so that's what they should have been doing with the S25 machine, but it's harder to test hardware, but still, they should have been doing more tests for sure. All right, any questions, thoughts about that? So that's, I think, where I want to stop in the lecture for the day. Are we good to go to our essay assignment? All right, so yeah, we'll come back to here. Fun ideas, and I'll have to give you this code. Why not? So I'll save that so I can give it to you. The last thing I want to do today is talk about your next essay. This is going to be a bigger essay, so you got 2 weeks to do it. All right, plenty of time, but this is going to be, I think this is the longest essay yet. All right, so I think I warned you about this one. I told you that's going to be fun, but this one is going to be 1,000 words. All right, do not worry, because you're going to be copying and pasting a lot of stuff from the internet. So don't worry, you're going to hit the 1,000 words pretty easily, I think. But there are a lot of instructions in this essay assignment. So please, before you get started, read every single line of these instructions. All right? Every semester I have to mark people down for not doing it right. And so please, please, please read these instructions and ask me lots of questions if you're not sure about one of the instructions. All right? So this is probably the most exciting essay I'm going to give you this semester, but you do have to follow the rules. All right? So here are your directions. All right? I want you to go on the internet and find people messing up in their arguments. All right? I want you to go on like Instagram, go on YouTube, find comments, find tweets. That's probably the easiest place to find issues. I want you to find 5 fallacies in arguments posted on social media. All right? So go on your favorite, go on TikTok, go on Facebook, go on Twitter, whatever its name is now. There are plenty more fallacies than we talked about in class. All right? So there's a huge list on Wikipedia. You can use any of these. Find any fallacy you want, but remember that every fallacy has a name. I want you to find a bunch of fallacies on the internet and list which kind it is and analyze which kind it is. Like, this was a straw man fallacy, this person posting this. Does that kind of make sense? That's what I want you to do. You're going to find a bunch of those. I think it'll be fun because you can search. You're already on the internet, I assume. You're already on social media. Just read some comments and try to pick them apart more than you already do. All right? So you can find any fallacy you want, even on the Wikipedia page, including the ones from class. You can find any of them. You do not have to use any computer science topics. Go where you already go, I think would be the best thing. It'll make it the most interesting for you. But if you want ideas, here are some computer science-y ideas. You do not have to find any of those. Go on Reddit, go on wherever you're already on. Go to the comments and look for issues. All right. So here are your main directions. I like a 1,000-word essay, please, with a normal essay setup, intro, conclusion at the end, and then the meat. What I want. A bunch of at least 5 paragraphs in the middle where you do the following, right? I want you to quote a social media post. Give me some background information if you need to. Here is a quote from the internet. I found this on Instagram or something. And I would like you to analyze why that post that you just quoted has a fallacy in it, right? There's an ad hominem fallacy in this post because this person called this other person stupid. Does that make sense? That's what I want you to do. You have to say the name of the fallacy. You can't just this is a fallacy. Next paragraph. All right. You got to tell me which one it is. They all have names. All right. So keep that in mind. I've marked a lot of people down because of this. So just make sure there's a name to your fallacy. Analyze why it has that fallacy. And that's pretty much it. That's the meat. That's what I want to see. A bunch of examples of people being wrong on the internet. I want you to explain exactly why they were wrong. All right. Why their argument had a fallacy in it. All right. That's the main idea. I think if you're struggling to find examples, the best place would be a news agency's Twitter account, YouTube account. Go to the comments for political posts. All right, something came out from the White House and they did a YouTube video about it. Go look at the comments for the news station. Suddenly people are going to be arguing about it. Okay, does that kind of make sense? If you're pressed to find things, I assume you're going to find plenty on wherever you already are on the internet. But that's going to be what your essay looks like. Okay. Show me 5 things, 5 fallacies, and name them and analyze them. Are there any questions about those requirements? Those are the main requirements. Just if you follow those, you get credit. All right? We're all going to say the name of the fallacy and analyze it. Get the full credit. All right. So the last requirement is, I know that people like to call each other names on the internet a lot. So the ad hominem fallacy is when people do that. I don't want your entire essay to be full of ad hominem fallacies, all right? It's by far the easiest one to find. So you can use it twice. You can find 2 ad hominem fallacies max, all right? The rest have to be completely different fallacies, all right? Are there any questions about that? So those are your main requirements. Go find people being wrong on the internet. You don't have to cite anything. Just try to quote the social media post. You can tell me where you found it. You don't have to like include a full citation for that. Some people like to include screenshots, like that works too. Whatever you like. So yeah, I think that's the main idea. 1,000 words though, 5 fallacies. It shouldn't be hard to get to 1,000 words because you're gonna like copy and paste the argument that you find on the internet. You're gonna be quoting it. All right. But yeah, find people being wrong. Doesn't have to be about computer science topics. Analyze the fallacy, say its name. Due in 2 weeks. Good? Questions about that? All right, I can tell we're all ready to go 5 minutes early, so go for it. I'm done now.